record. Okay, so now we're recording, and we're gonna get started. All right, so let me pull up the 1.3. Sorry, 1.4 lesson. My bad. Okay, so 1.4. What is it about? This is about measuring and classifying angles. An angle is a pretty simple thing. I mean, you guys see angles. You guys deal with angles all the time. But in the world of geometry, an angle is simply going to be two rays with a common endpoint. And if you have a hard time reading my handwriting, please just let me know. Or if you need me to clarify something, let me know as well. I do talk fast. I'll try to enunciate. So again, if you need any clarification, do not hesitate to speak in your microphone or type in the chat, and I'll address your questions. So that's all it is. It's two rays with a common endpoint. So here you got ray QT, you got ray QR. What's a common endpoint? Q, right? Obviously, going in different directions, right? One's going towards point T, one's going towards point R. And then there's an angle measure that we'll need to consider. There's an angle measure. And we're going to talk about angle measures in just a little bit. Where they meet is called the vertex. So the vertex is point Q. That's where they meet. And again, two rays at the same endpoint. And how do you call it? How do you name it? You always put the vertex in the middle. Because naturally, if you were to go in a certain order, you can go T, Q, R, or R, Q, T. Either way is fine. Just like lines, you can say line A, B, B, A, right? You know, segment, same thing. But angles, same thing. You could, but you do have to have the vertex right in the middle. So any questions about this first slide? Okay, we're good? Great, let's keep moving. Now, we will have to work with multiple angles. So obviously, you know, you have like SQT here. And let's use a different color. We use green. You have TQR right here. Now notice that TQ and RQT are the same. They reverse the T and the R, but the Q is still in the middle. Also, SQT, TQS, those are the same, right? And then you got the whole angle. You got the whole shebang here, right? SQR and RQS. If you think about it, angle SQR, the whole thing, is going to add up to angle SQT plus TQR. So if you were to, you know, let me erase because it got a little busy there. If I call this like angle 1, I call this angle 2. So SQT is angle 1, TQR is angle 2. Clearly, those added up would get you the big thing, SQR, right? By the way, we actually call this AAP, angle addition postulate. We had a segment addition postulate. We also have an angle addition postulate. So we will be adding angles later today. And remember, postulate is something that's obvious. Like, yeah, obviously, add those two, that's the big thing, right? And then if you look at the directions here, how many different angles can we name from the figure above? Well, we named 6 different, well, actually, technically 3 different angles, angles 1 and 2, and then the whole thing. But angle 1, which is SQT, could also be written as TQS if we reverse the letters, right? So questions about this slide at all? Ray, okay? Perfect. Okay, good.
Yeah.
Great, thank you. Whoever that was. Okay, let's keep moving. Now, degrees. A degree is a way to measure an angle. So when you think of measurements, right? Let's think of like length. How do you measure length? You know, we could use feet, or we could use meters. You know, if you're in a different country, you know, we are special in this country. We like to use our own unit, but other countries use meters or kilometers. So like if you go travel, say, you know, I know some guys went down to Mexico, right? If anyone's going to Europe, you know, when you look at the speed limit, they'll say it's in kilometers per hour, right? They don't do miles per hour. Or if you go to a gas station, they do liters, right? So volume, or in whatever monetary unit they have in that country as well. We use gallons in this country. Like gas is like 650 a gallon, which is crazy. We use liters. Sorry, other countries use liters. So those are units, right? But for angles, that's kind of a common thing regardless of where you are in the world. We use a degree to measure angles. And hopefully, this is something that seems intuitive. So this right here, does anyone want to tell me what I just drew? You can type in the chat, or you can just speak in your microphone. What did I just draw?
Angle.
Totally a right angle, exactly. And it's 90 degrees. Like intersections, usually road, street intersections are usually at right angles, unless you live in a weird neighborhood or there's a weird, like I live in Arden Park, so Fair Oaks and Watt, those are totally at a right angle, right? So yeah, so we look at angle measures. Just 360 degrees is a full circle, right? That's a full circle. Is 360. 180 is a half circle. Sometimes we use 180, like if someone does a 180, they're like going in the opposite direction. Like sometimes we use that as a figure of speech. Like if you're in a really good mood and also in a really bad mood, you've done a 180. But anyway, that's just half a circle. So you can see in this circle here, there's different angles. There's T, Q, R, and obviously it could change. It can get bigger or smaller. So that should be pretty straightforward. Yeah, I guess it comes from the fact that we have roughly 360 days in a year. So the Earth rotates in a circle, but again, 360 degrees full circle, right? So that should be pretty straightforward. Any questions on this slide? All right, let's keep moving. Classifying angles. So we just talked about right angles. There's acute, which is less than 90. I remember probably in 4th or 5th grade, many years ago when I was in school. Sounds like cute, small. I have 2 small kids. Like a lot of people think my son and daughter are both very cute kids. I don't know, like when you're a toddler, you think they're cute. I don't know if that makes sense, but cute's going to be small. Obtuse. Obtuse is a big angle. So it's more than 90. And then straight is a 180. That's a straight angle. So those are classifications of angles, should be very straightforward. No pun intended with the straight angle. And sometimes we use this little M symbol here to denote the measure of the angle. There we go, to denote or to specify the measure of angle. And then we use a degree symbol to indicate that we're using degrees. Now, there is another unit called radians. I don't know if we're going to get into that in this class. Maybe when we do trigonometry, we'll cross that bridge if we have to. That probably won't be until after 4th of July. But yeah, there's another, like for example, you don't always have to measure length in feet. You can measure in meters, right? Same thing with your weights. You don't always have to measure in pounds. You can measure in kilograms. So there is another unit of measure for angles. We call it radians, but we're going to just focus on degrees because that's more intuitive. It's what we're used to. Angle distribution postulate, boom. I talked about it a few minutes ago. AAP. It's very, very simple. The 2 smaller angles adds up to a larger angle, right? So call this angle 1, call this angle 2, right? It's going to add up to the big guy. Likewise over here, if I call this 1 and 2, here's angle 1, here's angle 2, add them up, it gets me the big thing, right? Yeah, nothing too complicated there. Questions on this slide, on slide 5? All right, just to pace myself. Okay, so we're going up to slide 8. Okay. Okay, so here we have a computation. So you are told that QRX, and let me get a highlighter here. QRX is 2x plus 2. And this right here, which is XRS, your total is x plus 1. Okay, this is the beauty about Zoom, is that you have these nice annotation tools, right? So those two guys are going to add up to the big one, which is QRS. That's a big guy right here. And again, remember, QRX is what I have in green, or yellow, actually, the same thing. It looks the same. And of course, this right here. So, and you're told that QRS is a right angle. Okay, I gotta remember what colors I'm using now. There we go. It's a right angle. So what this means is that that's 90 degrees. That's why 90 is going to equal 2x plus 2, which is QRX, one of the smaller angles, plus x plus 1, which is XRS, one of the other smaller angles. And then it becomes just algebra at this point. This is why we're doing a lot of review of algebra, right? So you combine like terms on the right side, 3x plus 3 collect like terms. Move the 3 over, you get 87. Divide by 3, you get 29. Done. X is 29 degrees. But if you actually want to find out what QRX is exactly, you do 2 times 29 plus 2, which is 58 plus 2, or 60 degrees. If you want to know what XRS is exactly, well, then just do 29 plus 1, 30 degrees. And what's 60 plus 30? 90. There you go. So questions about this competition. So the worksheet's going to be a lot like this. The worksheet we're going to do in just a little bit, which you guys should already have hard copies of. Okay, we're good? Great. Congruent angles. When two angles are congruent, that means they're the same or equal. So we use this symbol here, just like we do with line segments. So for example, we say P and R, those are the same. Or T and S, those are the same. And we use some markings to show that if we see like, one marking on each of the angles, those are the same angles. Or 2 markings on 2 different 2 angles, those are the same. And we're going to be dealing a lot with congruent triangles, like triangles that are identical or the same or equal, meaning that the angles and the sides are also going to be the same. And just to rephrase, corresponding sides, corresponding angles. We're going to cross that bridge later on. But congruence is a thing that we talk about often in this class. It just means equal, the same. And so in this case, you see like, angle P is the same as angle L. So angle P and angle L, those are the same. And they're color-coded like that. Or like Q and J. Q and J are the same. Those are color-coded. Or R and K. R and K are the same. Those are color-coded. Bisecting. We talk about segment bisecting, cutting in half. The bisecting to cut in half, right? That's exactly what we're going to do here. We're going to cut this guy in half. So we see here that we have 77 degrees is the whole thing here. If you add 38.5 to 38.5, but RX is called the bisector, so it just cuts QRS in half. So it means that QRX and XRS will be the same. And I guess they happen to be 38.5. So just cutting in half, that's all it is. So that's an angle bisector. And I think that's as far as I want to get for 1.4. So now let's look at the worksheet. Let me open it up. And by the way, I do want to go over this homework. I just realized I should go over the evens with you guys. We'll do that after our break. And if you want to ask questions, feel free to do so. And thank you for uploading your work. I took a quick peek of some of your work and it looks good. You guys are staying on top of it. I'll update the grades either late tonight or early tomorrow morning. So let's pull up the not 1.3, sorry, 1.4. Here we go. So I'm gonna get us started. You close. Okay. I'll get us kick started, and then I'm going to have you guys then do this. You could just do this kind of individually, or you could talk to each other. But I'll do kind of like one problem from each group. So for number one here, you're asked to write 3 names for the angle shown. Name the vertex and the sides of the angle. Okay. So you could say angle E. You can call it that. You can also call it angle DEF. You can also call it angle FED. So you do have the freedom of just putting a single letter, the vertex, or you could use the other 2 points, and you can go in any order, DF or FED, but E's got to be in the middle still. The vertex is E, and the sides are ray ED and ray EF. You have to remember as rays, just so you know. Okay, so let's do this as a group chat. And it's okay if you miss questions. Don't worry, totally okay. So what I'd like you guys to do is just type in the chat what you think each of these classifications will be. So DFE, which is right here, is DFE going to be acute, obtuse, right or straight? Angle AFB, is that going to be acute, obtuse, right or straight? And then CFE and AFE. And so you could just like type in the chat, like, number 2 is this, number 3 is this, number 4 is this, number 5 is this. So go ahead and do that right now. Should only take a few seconds. And I'll take a look at the chat once we get more people chiming in. So, and don't be shy. I do see one person in the chat. I know more than one of you guys can do this. Okay, good. I see 2. I feel a little better. Okay, good. I'm seeing some good stuff here. So I'm seeing people saying acute, obviously. I'm seeing people saying acute again for AFP and DFE. So good work there. CFE, obtuse. Very good. And AFE straight. And let's just take a look at the chat. Yeah, 2 is acute, 5 is straight, 4 is obtuse, 3 is acute, 3 is acute. Good. Excellent. Thank you guys for chiming in there. Perfect. Okay. So I'm going to do 6 and have you guys try 7, 8 on your own. For 6, you're asked to find PRS, which is the whole thing. Well, PRS is going to equal PRT plus TRS. Well, PRT, 81, TRS, 42. Add up, you get 123. Not that hard. Pretty straightforward. 122 degrees. So I'll have you guys try 7, 8 on your own. But 6 I just did for you guys. 9, let me set it up. So this guy plus this guy has to add up the big angle. ADC is a big angle, right? That's the whole thing. So 7x plus 11x plus 9 has to equal 135. Then it becomes algebra at that point, right? You combine like terms, 18x, and you're going to subtract 9 from both sides, right? Just algebra. What's that going to be? 126. Use a calculator, by the way, if you don't want to do this in your head. I could do this in my head, but actually, could I do this in my head? What is that? I think 7. Yeah, I think 7. Do check using a calculator, or if you have a cell phone, or you could use Desmos or whatever, or something on your computer. Yeah, that'd be 7. So then, but we're not done yet, because we want BDC. They're going to do 11 times 7 plus 9. 77 plus 9 is 86. And there you go. And 7 times 7, by the way, is 49 degrees. And those two do add up to 135. So, but A6 is what we're looking for as the answer. Right there. So you'll try 10 on your own. Very, very similar to what we just did. Let me talk about 11 and 14. Then I'll have you guys do the rest of the problems. So for 11, if you're told it bisects, means cuts in half. So that's obviously 39 degrees. So angle ZXY is 39 degrees. You're asked to find two angle measures. Also, angle WXY is 78 degrees. That's the whole thing. So what you're asked to do is you're asked to find one of the smaller angles and then the big angle. That'd be for number 12. For number 13, actually, they do give you the big angle. 146 is the big angle. So you got to find the two smaller angles. And it's bisecting means cuts in half. And then lastly, more algebra. So 5x plus 2 is going to equal 7x minus 6. These are the same, because it bisects, right? Cut in half. So the two smaller angles are identical. And you're told that one of the small angles is 5x plus 2, the other one's 7x minus 6. So then you got to do some algebra. So remember, you got to combine like terms. So maybe move one of the x's to one side. So you got this. Move this to the other side. So 2x equals 8. Divide by 2, x equals 4. But then you're asked to find the measure of angle ABC. That's the whole thing. So this is going to be 20 plus 2, which is 22. This is going to be 28 minus 6, which is also 22. So the whole thing is going to be 44. And that's a great way of checking your work too, because when you do plug in whatever you solve for x into each angle, they should be the same, right? If they're not the same, then you made an algebraic mistake or maybe a careless arithmetic error. And then once you get the measure of each of the smaller angles, add them up and you get the big angle. That's what you're supposed to do for 15 and 16. So questions before I have you guys do some problems.
I have questions
far away.
on number 12.
Yeah, let's go back to number 12. Sure, go ahead. So remember, it's cutting. So what's your question?
Can you go through it and explain it?
Yeah. So you see how so xz bisects means cuts in half, right? So this is 1/2 right here. So what do you think this is going to be right here then?
The other half?
Exactly. It's also going to be 57.
Oh, okay.
They're equal, right? And then the whole thing is 114. So what you're going to say is that WXY is 114 and YXZ is 57. That's all. All right, so I'm gonna have you guys do 7, 8, 10, 12, 13, 15, 16. So I'll give you guys a few minutes. Type in the chat if you have questions. We'll check in. So we'll say in about 7 or 8 minutes from now. And once you're done, you can just give like a thumbs up, or you could just type in the chat you're done. And I'll just hang tight here until we're ready to talk about it. And then once we finish this worksheet, we'll do a small break. Okay, we'll check in about a couple minutes. Okay, let's start going over this. For number 7, EFG is the whole thing. Hope we got 56. That's 37 plus 19. WXZ is a portion of the big angle. The big angle is 90. So 26 plus WXZ has to equal 90. So WXZ is going to equal 64. So that should be 64 degrees. And I believe the answers are at the end of this worksheet. Some of them are, not all of them. Looks like the odds are. But I do see 56 for number 7, so that's good. Okay. Let's look at 10. So 10 is some algebra. So NRQ is the whole thing. So then that means that 8x plus 7 plus 4x minus 1 has to equal the whole thing. And you're not going to set those equal to each other because you're not told that this bisects, right? We'll do that for the other problems. But this is, you're adding, it's AAP, angle addition postulate, because, you have these two smaller guys that add up to the big guy, right? So 12x plus 6, remember you got to do your combining like terms first. Then you got to move some terms around. Subtract 6. 12x equals 72, x equals 6. Okay. So x equals 6. And then we got to find P or Q, which is 4x minus 1. So 4 times 6 minus 1, you should get 23 degrees. So that should be 23 degrees for that one. And again, I am recording this. Any questions on number 10? That was good. Okay, great. For 12 and 13, so remember, if you're told this cuts it in half, that means that these are going to be the same. So that's also 57. And the whole thing is 114. 146 is the whole thing. So WXZ is half of that. Half of 146, which of course will be 73 degrees. And ZXY or YXZ, however you want to call it, just got to put X in the middle. That's also 73 degrees. So those are identical because it bisects, right? And then here, again, you're told that you're doing the bisector and you're given both the small parts. So you're going to set those equal to each other. Adding is not going to do anything for us. We have to set them equal to each other, just like we saw with the segment bisectors, right? When we're bisecting segments, each of the halves were the same because they're both halves, right? 11x minus 12 equals 8x plus 3. You should get 3x equals 15 because you got to move the negative 12 to the right, the 8x to the left. X is 5, just doing your algebra correctly. Here, 5x plus 13 equals 9x minus 23. So you got to move the 5x from left to right, that's 4x. The negative 23 from right to left, that's 36. X equals 9. But then you're asked to find ABC, the whole thing. So what you could do is do 11 times 5 minus 12 to get one of the halves, which is 43, and then multiply that by 2. Or here, you can take one of the halves, like say 5x plus 13, so 5 times 9 plus 13, which is 58. Multiply that by 2, you get 116 degrees. So that's how those would work themselves out. All right, so that completes 1.4. Questions at all? Yes, Vivian, go ahead.
I was wondering if you can go over question 13 again.
Sure, yeah. So 146 is the whole thing. And Nina, you have a question too. Was it the same or a different question? Same one?
Yeah.
Yeah, so it's kind of weird. And I can see why probably you were confused, because, you know, what does that mean? WX, Z, and ZXY separately? Or does it mean the whole thing? When they do that, that means the whole thing. The whole thing is 146. So WXY is 146. And it cuts it in half, right? Bisect means cut in half. So that's why I multiplied by 1/2. And you can use a calculator, by the way. You know, calculator is fine, but if you do think about it, if you have like 146, it's 140 plus 6, right? 146 is 140 plus 6. So if I divide that by 2 and divide that by 2, I get 70 plus 3, which of course is 73. And that's also 73. Each of the halves are identical because it is half, right? So again, the whole thing's 146, and you multiply by 1/2 or divide by 2, same thing. Did that help?
Yeah, thank you.
Cool. Yeah, that's all you're doing, just cutting in half. That's it. But 146 is the whole thing. Okay, well, it's 9:53 right now, so let's take a break. Let's come back at 10 o'clock. So it's just a short break, so you can get up, stretch. I'm actually going to go to the kitchen and get something. But yeah, just go ahead and let's come back at 10 o'clock. I will pause the recording because it's not really. Okay, it's 10 o'clock. Let's return. We're going to do another lesson on 1.5. So make sure you have your slides out. Let me share my full screen. Okay. So I'm going to go and close this up down here. Oh, let's talk about homework number 1. So let's do that first, because I should always talk about the homework with you guys. So you guys have the odds here. The odd answers 1, 3, 5, 7, 9, 11, 13. It looks like 15 was not discussed. That's interesting. Wonder why. But before I do the evens, any questions about the homework that you're confused about that you want to ask? Feel free to raise your hand or type in the chat or speak in your microphone. Any questions for this homework that you guys wanted to talk about? Yeah, Nina, go ahead.
For number 5, I didn't know how to really set it up. It's answer in the answer key, but I didn't know how to set it up. And I think the lettering also confused me a bit, like UV and WV. I thought maybe it was
It's weird because they didn't tell where U is, right? It's interesting. Well, I think when they say something it's bisecting, so it's just cutting in half, right? The visuals helped for 1, 2, 3, obviously, but they're just saying that this line here cuts this in half. So you just take half of 58. That's all, which is 29. And again, feel free to use a calculator if you need to. Like, for example, if I just use the one in my computer, no, not the calendar, that made no sense. Calculator. Yeah, if I just do 1/2 times 58, I get 29. That's all. So don't overcomplicate it, but yeah, it was a little confusing because they didn't really tell you where U was, but yeah, just 29. And Sean, go ahead.
Can you do 4 as well?
Number 4 is stick with 4. I think it's just the same exact thing. So this is what they're saying. AC is like this. I should probably draw for you guys. So that's 11 and 1/8. And then B is right in the middle. So AB, that's going to be half of AC, or half of 11 and 1/8. And that's where you could just use a calculator to do that calculation. I'm actually going to pull up the graphing calculator. It's a little more sophisticated than the one on my computer. So all you do is do 1/2 times, nope, take 2, 1/2 times, and then 11 plus 1/8. And you get that. And you can leave it as a decimal, it's totally fine. If you want to convert that to a fraction, you can subtract by 5. And then there's a feature in the graphing calculator. If you go to math and then frac, it converts that to a fraction for you. So it's 5 and 9/16. So use a calculator to do that computation. It's a little confusing. And we see more people have hands raised. Ellie, go ahead. I see your hands raised.
Yeah, I'm confused on number 18.
18, let's go over 8. And Nina, you have your hand raised again too? What's your question, Nina?
Do you prefer using decimals or
I don't care.
fractions?
Doesn't matter to me.
Okay.
Yeah. I'm
Because
flexible.
I also like rounded the
If they do tell you to round, you should obviously. I'll specify. Yeah, usually it's round to the nearest 10th. So to one digit after the decimal point. That's usually fine.
Thank you.
Yeah, you're welcome. All right, so let's look at this guy here, number 18. Player A kicks to player B, who then kicks to C. How far did player A kick the ball? So you have to solve this. That's the first thing you have to do. And we have to use Pythagorean Theorem. Or distance formula. This side's going to be 9, and this side's going to be 4. How do I know that this side's 9? That's 12 minus 3. Because you have a 12 here. Let me get the highlighter out. You have a 12 here and a 3 here. So the horizontal length is the difference in x coordinates, right? The difference in x coordinates is a horizontal length. 12 minus 3 is 9. And then the other side is going to be 4, because you're doing 18 minus 14, right? The difference in the y coordinates. So the vertical leg is 4, 18 minus 14. Then we do Pythagorean Theorem, right? Remember, Pythagorean Theorem is this. A squared plus B squared equals C squared. A and B are the legs, right? A and B are the legs, and C is the hypotenuse. So it's going to be 9 squared plus 4 squared. And whether you put 9 in A or B's position doesn't really matter, because they're both on the left side. And they put 4 in A or B's location, doesn't matter. If you do the 9 squared, you get 81. 4 squared is 16. You get 97. And then C is root 97. And you leave it like that. So that's how I'd approach that one. If you so desire, you could use a distance formula, which is in the notes, which is the difference in the x coordinates squared plus difference of the y coordinates squared. So you take the difference in the x coordinates, 12 minus 3 squared, difference in the y coordinates, 18 minus 14 squared. I did that anyway in Pythagorean Theorem. It's just Pythagorean Theorem gets you away from the formulaic process and makes it more visual, which I think might be a better way to learn it. And then for part B, do the same exact thing. Same exact thing. The horizontal leg is 5. The vertical leg is 8. 14 minus 6, 8. 12 minus 17, or 17 minus 12 is 5. Shooting 8 squared plus 5 squared equals c squared. 64 plus 25, that's 89. So c is root 89. Hopefully that makes sense. So Ellie, did that make sense?
Yeah.
Cool.
Thank you.
And let's do some other events. Oh, C. How far would we have to kick to get to C? Okay. You get the idea now. So it's just this here. So you have to draw another triangle and rinse and repeat, right? 3 and 17 is 14. 18 minus 6 is 12. Remember that's 18 minus 6 here. Remember that's 17 minus 3 here. And just, yeah, 12 squared plus 14 squared, right? And you get 144 plus 196, which is a pretty big number. That's 340. So root 340. 16 works the same way. That's 7. That's 5. That'll be root 74, I think. So that's 16. 14, you're asked to find the midpoint. So you just got to take the average. So you get 4, 5. And you have like examples to follow for 13 because you have the answers there. If you have a midpoint, you have to obviously set these equal to each other and solve. So that's 43, and that's also 43. So the whole thing is 86. You would do the same thing over here. So you guys set them equal to each other and solve for x. So that's that one. And I do, I will work through these and scan and upload all the solutions we have them to view. I haven't had a chance to do it because I was busy watching the NBA finals, got the trophy. So 10, again, same thing. It's being cut in half, as well as 8. So in this case, 2x will equal 6, x will equal 3. This case here, 3x equals 24, x equals 8. So MF is just going to be 15 then. JK, the whole thing, one of these things is 59. No, is that right? Wait, 6 times 8 is 48 plus 11. Yeah, 59 times 2 is 118. The whole thing. Okay, cool. I think I addressed all the evens here. They didn't talk about 15. I don't know why, but more the same thing again. Just Pythagorean theorem. That's 4 and 5. That'll be root 41. You work that one out. Okay, so we do need to move on to our next lesson. Okay, 1.5. Let's see. It should only be a few slides. So let's see. This goes to the slide 14. Okay. So angle pair relationships. All right, some more terms to throw your way. Yeah, and I do want to kind of give you guys a terminology sheet too. So let me work on that over the weekend. Let me make that a task for me to do. So I do have to put together some video lessons, Google Forms for next week. Great homework. Homework solutions. Cool. Okay. Complementary. Complementary means two angles apt to 90. Very simple. So 36 and 54 are complements of each other. They apt to 90. Or here, 55 and 35, those apt to 90, those are also complements of each other. That's all. Just adds up to 90. Nothing more to it than that. And that's just something we'll see often in this class. We'll talk about. Supplement means add up to 180. And again, the way I remember this, probably in 4th or 5th grade, I remember we talked about this. Supplement sounds like supply, sounds like you have more when you have a supply of something. So supplementary is going to be the 180 situation. Complement is a 90 situation. So 1 and 4, obviously apt to 180. There you go, right? So there's two angles apt to 180. That's all it is. Don't overcomplicate it. Adjacent means next to. So what's next to angle 1? Obviously angle 2. So they're adjacent. 1 and 2 are adjacent. 2 and 3 are adjacent. But 1 and 3 are not, because they're not next to each other. So it's just another term. Adjacent means next to. That's all it is. Linear pairs is two adjacent angles, and basically they form a line. Or a straight angle. So basically there are two rays that go in completely opposite directions. And they share an endpoint, but they go in opposite directions. So like here's ray A, or sorry, ray AB and ray AX. Or they could look like this. And again, they're non-common sides. So for example, they're non-common sides are those right there, where this is going this direction and that is going that direction. Clearly this right here is a common side for angles 1 and angle 2. Obviously the L is a common side, but the non-common sides are opposite rays. So the white parts, as you see right there, form two opposite rays. So we call that a linear pair because the two angles form a line. So for example, if this were 140 degrees, this would be 40 degrees. So they add the 180. It's also the same as supplementary angles, as we just said a few minutes ago. Same thing as supplementary angles. I think this is probably 2 more slides. Okay. Vertical angles is another one. Vertical means they're just opposite of each other. So 3 and 6 are vertical angles. 4 and 5 are also vertical angles. So if I do some markings here, 4 and 5, 3 and 6. So 3 and 6 are the same. And the vertical angles are always equal to each other. So they're mirror opposites of each other. And this diagram right here just shows like, you know, the reflections, right? So one is as a angle 1 is a reflection. Let me write that more nicely. Angle 1 is a reflection of angle 2. You can think of it like that as well. But when you have two angles that are directly opposite of each other, those are vertical angles. And also they say they form opposite rays, which kind of makes sense. Yeah, you can see the greens and reds are opposite rays of each other. So are any of these angles below vertical? The answer is no. So you have to make sure it's two intersecting lines. So like, for example, that's not a line, right? That's not straight. That's not a line, that's not straight. So none of these angles are going to be vertical. So it has to be two pairs of opposite rays, right? So you have that. And you have that. But also you can think of this as this is one line, and that's another line. You think of it like that as well. Okay, so what we're going to do is this. I'm going to put you guys in breakout rooms. And I'll kind of pop in the rooms, see how it's going. So that way you guys can interact with me a little more in a smaller group. So it's about 10:20. This is good timing. Let's look at classwork 5. This should be, I think, 2 pages, 3 pages actually. Okay. So there's a warm up here with some old stuff. And then there's some, more of the stuff we talk about, defining these terms, complements and supplements, name the complementary name, subtary angles, name, all this stuff, and name the adjacent angles, finding complements and supplements, working out some algebra here. Yeah, so this might take a little while. I would say this is only about 20 minutes or so to do this worksheet properly. So let's do this. We have 17 of you guys here. I'll make I guess 5 breakout rooms, and I'll kind of split my time equally. I'll probably spend about 4 minutes in each room to see what kind of questions you guys got. And I'll pause the recording as well. Okay, so now we're recording again. So let me share my screen. And I just emailed myself a scan. Here we go. Okay, perfect. There we go. So here's a scan of my work. So I'm going to go through all this. And if you have questions, don't hesitate to speak to the microphone, raise your hand, or type in the chat, and I'll address your questions. I did go through the breakout rooms. It seemed like you guys were off to a good start. Now, for this first problem, it's translating, right? 2 numbers add up to 90. And one number is 4 times the other. So if you call one number x, the other number would be 4x, obviously, right? And they add to 90. So x plus 4x equals 90. Solve it, you get 18. That means that one angle is 18, the other is going to be 4 times it, which is 72. And use a calculator if you need to. For 2, they want to measure angle ABD. Well, you have ABC and CBD. Those add up to 180, and it's a straight angle. Sadie, go ahead.
Anil said that that he's not going to be joining the whole meeting.
No worries, it's all good. I'm recording it. I'm going to show you record. You can watch it when he gets a chance. That's not a problem.
Okay, cool.
Yeah. Thank you for that update. Then here, this is more labeling. Like name a pair of complementary angles. So I put a little note here. You got to add to 90. These 2 guys add to 90. Therefore, that's why I said CAB and RST. If you said BAC and TSR, same thing. Just make sure the vertex is in the middle. Supplement means you have to add to 180. So 122 and 58 add to 180. That's why I said CAD and RST. And adjacent means it's got to be right next to each other. Obviously, VAC or CAB and CAD are right next to each other. So you got that. We'll keep moving here. Name a pair of complementary angles. Same thing again. They have to 90. These two have to 90. So FGK, GKL, apt to 180. These guys have to 180. So KGH and GKL apt to 180. Adjacent's got to be right next to each other. These are right next to each other. FGK, HGK. Very nice. Question on the first page. Pretty straightforward. Okay. And I'll make sure I'll upload these, and I'll create a folder for solution keys so you guys can check all that stuff, because this will help you for reviewing for our test next Thursday. But I'll try to get this, these uploaded by late tonight or early tomorrow morning. I usually go to bed after my kids go down. I get up before them. I don't sleep much. So anyway, 1.5.2. Complement means you have to 90. So if one of them is 68, you do 90 minus 68. So it means apt to 180. So if one is 56, 180 minus 56, 124. Supplement means add to the 180. So one is 117, 180 minus 117 is 53. Here you have a diagram, and it's pretty clear. Well, I shouldn't say it's too clear. I had to take a closer look, but that's one angle. That's another angle. And you have 4x plus 8 and x plus 2. They have to add the 180 because they're supplements, or they form a straight angle. And if you work it out, you get x is 34. Then you can put 34 into each expression, and you get 144 and 36. And then you try another situation. Now these are complements, so they have to 90. And you're given both expressions. So you add both expressions, set it equal to 90, solve for x, you should get 7, and then plug in 7 to each expression to get the measure of each angle. Before I move forward, any questions on this stuff on the top half of page 2 that you need me to clarify again? Or if you need a moment to kind of simmer on it, let me know. Okay. Okay, then we're good. All right. And then these are some terms like linear pairs when two angles form a line, and they're also supplements. And opposite meaning that you have two lines basically intersecting, and angles opposite of each other are vertical angles. And looks like this person didn't know how to spell. It should be CAL. Anyway, sometimes a stickler of spelling. So we asked to find linear pairs. Remember, a pair is 2. You can't give 3 angles because that'd be a trio. That wouldn't be a pair. So that is totally a pair right here, 1 and 4. That is totally a pair here, 4 and 5, and they form lines. But you can't say, even though 2, 3, 5 forms a line, that's not a pair, right? That's 3 angles. Or if you said like 1, 2, 3, sure, 1, 2, 3 forms a line, but that's not a pair. Vertical angles, we do have 2 lines here, and 1 and 5 are opposite of each other. So those are vertical angles. The combination of 2 and 3 with 4, but again, 2 and 3 are 2 different angles. So you just want to give a pair of angles. 1 and 5 are vertical angles. Questions on how to find vertical angles or linear pairs? Okay. Let's talk about page 3. After we talk about page 3, we'll do another break, and then we'll talk about 1.6. And it looks like we're probably not going to get to 1.7 today, so I'll have to have that carry over to the following week. But that's okay, because I could totally squeeze that in. Or actually, what I might do is I might do a short video on, more I think about it now, I might do a short video on 1.7. So you try linear pairs. There are no linear pairs here. I mean, you have 3 lines all intersecting, but you don't have a pair of angles adding up to a line. So there are actually none here. Like 1 and 2 don't form a line. 2 and 3 don't form a line. 3 and 4 don't form a line. 4 and 5 don't form a line. 5 and 6 don't form a line. But because you got three pairs, because you got three intersecting lines, oh, come on, here we go. You're going to notice that 3 and 6 are opposite of each other. 1 and 4 are opposite of each other. 2 and 5 are opposite of each other. So 2 and 5, 1 and 4, 3 and 6. Then here, again, it's more of the same stuff. Like if you have a linear pair, they add to 180. And one angle is x, so it's 5x, so you just make an equation. Or if two angles are complements of each other, oh, crap. I messed this one up. Ah, darn it. Okay. Oh, goodness. This happens to do this too quickly. I thought, so, goodness. Let me, it's twice measure of its complement. Complement is as within the 90, I know that, but, so if this is x, that's 2 times 90 minus x. Because complement is 90 minus x. So x plus 2 times 90 minus x. Actually, maybe I didn't mess it up. Hold on a sec. Oh, equals it. Yes. Yeah, let me cross that off again. So that's x is twice its complement. There we go. Yeah, my bad. So x equals, so then x equals 180. So then, oh, actually, I still got the right answer. That's interesting. Okay, I just went about it a little bit complicated. Okay, well, let me just write the solution a little better here. So I still got the right answer. Just the wording was threw me into a loop. So I won't rescan it. I probably should just word it the same way like up above. That two angles are complements. One's twice the other. I probably should just word it that way. But in here, these are good problems. And I would say these are definitely test-like problems. So you see how this is a linear pair, right? So 9x plus 20 plus 7x, that's apt to 180. So 16x plus 20 equals 180, 16x equals 160, x equals 10. And then 2y and 7x are vertical angles, so they equal each other. Well, you already know what x is, it's 10, so 2y equals 70, y is 35. And then here, that's a linear pair. And here, that's a linear pair. So it's easy because you're doing single variables. So 4x minus 100 plus x plus 5 equals 180, solve for x. 2y plus 3y plus 30 equals 180, solve for y. We get y equals 30. So that covers the rest of that stuff there. Okay. Questions before we take a little break again? Nope. Okay. So let's do. Let me look at the pacing here just to see. Okay, so I can finish 1.6 pretty quickly. That should take me a few minutes. And so the worksheet for 1.6. That's pretty short also. So let's come back at say 11:10 Yeah, so let's come back at 11:10. And so 15 minutes. And then we'll finish off 1/6. And then I'll tell you guys your homework for the weekend. So yeah, so let's do a 15-minute break. So we'll get back in 15 minutes. Let's, all right, now we're recording. So let's look at 1.6. Or sorry, let's look at the slides first. Here we go. So there's only 4 more slides left here. Let me expand this. Oh, let me share my screen, obviously, so you can see what I see. Here we go. So polygons. Let's talk about polygons. A polygon is just simply a shape. That's all it is. And it's a plane figure. So it's, it's a plane. Or I mean, it's part of a plane. It's a closed plane, so it doesn't go on forever. So closed. Doesn't go on forever. It's formed by 3 or more line segments called sides. So like a triangle is the most basic polygon we can make, right? Each side intersects exactly 2 sides. So like, I'll call this like sides 1, 2, and 3. So side 1 obviously intersects sides 2 and 3, right? And 1 at each endpoint, so that no 2 sides with common endpoints. Yeah, so nothing's on, so you don't have 3 collinear points. Like if you had this here, that's not a polygon, obviously, right? That's just a line or a segment. Each endpoint we call a vertex. The plural of vertex is vertices. You don't say vertexes. That's kind of weird. You say vertices. A polygon can be named by listing the vertices in consecutive order. So A, B, C, D, or C, D, A, E, A, B, just in consecutive order. Doesn't have to be alphabetical. Yeah, so like this case, this is a polygon because you have this side here and it intersects just 2 other sides. But this side here, it's intersecting actually 4 sides. So that won't be a polygon. You could say this is a polygon and the bottom is also its own polygon. You could say that if you want. But that's what a polygon is. It's just a closed plane figure where you have 3 or more sides and each side intersects exactly 2 other sides. Now, another classification we have talked about the concave versus convex. Concave, think of it as like caving in. It's like caving in. So like if I drew something kind of like this here, that's concave. Also, a little trick you do is if you pick 2 points, if a segment is not fully contained, in the polygon, it's concave. Whereas here, see, that's fully contained. But like if I did this one again, oh, it's just a segment, sorry. See, that segment's not fully contained in the polygon. So that's concave, whereas this is convex. So convex, if no line contains a side, the polygon contains a point in the, that's kind of confusing the way that's worded. The bottom line is that every line segment you draw connecting 2 points is always going to be inside the polygon. That's convex. If draw a line, it's not fully contained, then it's concave. Yeah, that wording's really, I don't like that wording. If no line that contains a side of the polygon contains a point in the interior, that's just weird. Just bottom line, just draw a line. If the line's fully contained, or sorry, segment, if the segment's fully contained, it's convex. If it's not, it's concave. That's what we do. Just so you know, 3 sides is a triangle, 4 sides quadrilateral, 5 sides pentagon, 6 sides hexagon, 7 sides heptagon, octagon, nonagon, decagon. You don't really have to memorize these. I mean, obviously know these right, those two. That's kind of important. I mean, hopefully pentagon, like there's, you know, our security or Secretary of Defense, our Defense Department. Sorry, I'm fumbling my words. Our Defense Department is housed in the Pentagon. Octagon. If any of you guys watch UFC or MMA, I used to, but don't really anymore. It's a little too violent for my be on the TV. My kids might accidentally see it. But you know, the octagon, that's an 8-sided ring, right? You know, so hopefully that helps you remember that. Hexagon, 6, but don't worry so much if you don't have those memorized. But do know a triangle, quadrilateral, because we work a lot with that. Usually when it's a higher order, like 12, like more than 12 sides, we call it an n-gon. If you have 80 sides, call it an 80-gon. If you have like a 60 sides, call it a 60-gon, and so forth. And this is the last slide, it looks like. More terminology. So I do need to create a terminology sheet for you guys. One of my things to do. Equilateral means equal sides. Equiangular means equal angles. So if you have a polygon with all the sides being equal, like say this right here, say each of these sides are identical, then we say this is an equilateral triangle. Equiangular means all the angles are the same. Like if I had a rectangle and have a bunch of right angles here, that'd be equiangular. All the angles are the same. And if it's both equilateral and equiangular, we call it regular. So by default, an equilateral triangle is equiangular because each of these will be 60 degrees. So we all say it's regular as well. Or a regular pentagon, meaning all 5 sides are the same and all 5 interior angles are the same. An interior means inside, like, you know, like if you're an interior decorator, you're decorating the inside of someone's house, right? Or if you're doing, if you're painting the interior of your home, you're painting the inside of your house. Exterior, if you're painting the exterior, you're painting the outside of your home, right? So exterior is outside. So you could have exterior angles also, but that's considered an exterior angle right here. Or like if I have a triangle, if I were to kind of extend it out like this, that's an exterior angle, you know, so. Questions on some of these terms that we discussed? So this is more just terminology, not so much computations that we did on the previous lesson. So now let's look at the worksheet. Should be pretty fast. I think it's just 2 pages. Okay. So tell what the figure is a polygon. We have to have straight sides, first of all. Let's go back to the definition. I'll tell you one for sure is not. But we look at the definition again. It's got to have line segments, right? There are no line segments here. This is not a polygon. Nothing curved. Now both these are polygons. But look what I do here. I pick 2 points on the sides and that segment's not fully contained in the polygon. Here, no matter how I draw a segment, it's always gonna be inside the polygon. So for number 2, is that convex or concave? What do you guys think? Based upon the definition we just talked about. And look at your notes. You can type in the chat. Nina, go ahead.
Is it concave?
Concave, very good, excellent. And it caves in, think of that like that too, right? So obviously the other ones, it's opposite, it's convex. Mhm. All right, that was pretty easy. Then here, classify by the number of sides and tell whether it's equilateral, equating, or regular. Okay. So how many sides do we have for number 4? We have 4 sides. Here we got 6 sides. Here we got 5 sides. And here we got, oh boy, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 sides. So you call this a quadrilateral. We call this a hexagon. You call this a pentagon. And this one here, you call it a decagon. So this is going to actually be just a square. And it's regular. Because all the sides and angles are the same, right? And likewise here, this is also regular. Because all sides and angles are the same. So regular meaning all sides equal, all angles equal. Not true for number 6. And actually, it's not even equilateral or equiangular because you have some angles are different, some sides are different. Here, all the sides are the same. But 5 of the angles are the same. Then you have some really weird stuff happening. And plus it's not, this is a concave. You know, regulars has to be convex. So we'll just say it's equilateral because all the sides are the same at least. I mean, obviously that's a star, 5-point star. But you know, really, 4 and 5 are the ones we tend to work with a lot. Regular polygons where all the sides and all the angles are the same. So questions? Okay. Yeah, Nina, go ahead.
So what would number 6 be?
None of those.
Oh, okay.
Because you need all 5 sides to be the same, which they're not. So that's out. Then also you would need all 5 angles to be the same to be equiangular, which are not because of the markings. And regular is when all the sides and all the angles are the same. So regular is like a higher up, right? It's even more special. But you need both equilateral and equiangular to be regular. That's why 4 and 5 are regular. Because all the sides and angles.
Regular would be all sides,
And all angles.
Angles are equal. Okay.
So
Thank you.
square. A square is a great, yeah, square is a great example. Okay. Now we get some calculations that we'll do. See here. Let me set these up and have you guys work them out. Length of 2 sides of a regular triangle. So it means all sides are equal. So 3x minus 5 has to equal x plus 9. Because they give you 2 sides, right? So you're going to work that out. Here, equilateral octagon So these are the same because equilateral. So go ahead and work on what you get for x. And go and type in the chat as well. Should only take about less than a minute. Let's see. Someone put in the chat. X equals 7. I'd agree. Totally agree. And then the other one. Four. I would, yeah, I'd agree. Oh, I think so. Hold on. Yeah, because you have 20 equals 5x, x equals 4. Yes, good. So the length of each side then, if x is 7, you're doing 3 times 7 minus 5, which is 16. Or if you plug in 7 here, you get the same thing. Here, if I plug in 4, 20 plus 13, 33. Or 40 minus 7, 33. Okay, so you told all these are regular. You got to solve for x. So all you're going to do is this. It's really that simple. I'm really terrible doing threes with my mouse. No highlighter. Come on. Yeah, here. And because you see this is a square, all the sides are. Actually, hold on, we're missing something. Oh, 7x plus 8. Okay. It's like, yeah, you gotta have something on the side here, 7x plus 8. So a lot of just plugging, a lot of just plugging away, solving. Well, let's go and try it. Okay. Hopefully you're getting 3x equals 24, so x equals 8. Hopefully you're getting 2x equals 6. X equals 3. Hopefully you're getting 4x equals 44. X equals 11. And hopefully here you're getting 7x equals 42. X equals 6. And just to be sure that we did this right, if x is 8, that's 31. That's also 31. If x is 3, that's 8. That's 8. If x is 11, that's 6 plus 17, that's 83. 110 minus 27, that's also 83. 84 minus 34, it's 50. And that's also 50 right here. Questions? Nope, okay. Hold on a sec. Okay. Almost on this worksheet here. Okay, last one. You're told it's regular. So all the sides are the same. These are your sides right here. So 20x has to equal 12x plus 112. Also, all the angles are the same. You're given 2 of those angles there. Oh, hold on. Okay. So go ahead and work this out. Perimeter, just so you know, this is sum of all sides, in case you forgot. And then interior angles, just the measure of each angle, the length of one side. So go ahead and work those out. You have to solve 2 equations. You have to solve this equation right here and solve this equation right here. This will help you figure out that question and that question. And this will help you figure out that question. So give you guys a couple minutes to work that out, and we'll check in. I was just solving for x. You should have that. So it should be 14. As you're solving for y, you should have 6y equals 30. So y should be 5. What this means that each side is going to be 20 times 14, or 280. Or if you did 12 times 14 plus 112, that would be 168, also 280. So 280 would be length of each side of the pentagon. And if it's regular, it's a perimeter, by the way. The perimeter is 5 times 280. So you have 5 sides, all they're 280, so it's 1400 meters. And then the interior angles, you do 23 times 5 minus 7, which I believe is 115 minus 7, or 108. Or you could plug into the other expression as well. So hopefully that seemed pretty straightforward. Any questions about what we just did? You'll have a chance to do some practice for the homework. No questions? Yeah, the answers, some of the answers are there, not all of them. Okay. So good, okay. So that's 1.6. Now I do need to get going in a few minutes. Let me briefly talk about 1.7 with you guys. And then I think what I will do is I will share a video link to help you with 1.7 and have you do that worksheet, and then there'll be a practice test you'll do. So let me show you, there's no slides for 1.7. But there is a class worksheet here. So this is about finding area, perimeter, and circumference for different shapes like squares, triangles, rectangles, and circles. And so it's very formulaic. I don't want to rush this, so I'll definitely share a video lesson with you guys on this. So I'll most likely what I'll do is I'll probably do a video going through all this stuff here. And then there's a homework assignment that deals with the same thing. And I think the odds are there for sure. So I'll definitely have a video lesson that goes over the classwork, and then a worksheet to, for you guys to do for homework. And then there's a practice test. And also I'll work through the answer key on this as well and upload it. And so homework will be 3 things. It will be watching a video where I discuss the 1.7 classwork. Then it'll be completing this homework worksheet here, which is all in the packets that I gave you yesterday. But I'll upload it anyway. This is on the perimeter and area and circumference. And then the third thing is working through this practice test or test review for chapter 1. But again, we're not having our first test until Thursday because I want to combine it with chapter 2. So there'll be 3 items. I'll put it all in Schoology later. I should be able to actually upload this within the next hour. And yeah, that's pretty much it. So we do finish a little early, just because I do have to catch a plane to catch. Again, next week we're not meeting in person. We're meeting on Zoom 4 days in a row because I'll be out of town. And we will do from 9 to 9:30. We'll talk about the plan for the day, and I'll go over the overview of the worksheets, and I'll have video lessons to point you guys to. Then we'll meet from 12 to 1 live, where we'll talk about the videos and we'll do some practice problems together. And so that's how, and then we'll have a test on Thursday next week. So there'll be some asynchronous, some live lessons, just kind of mixing up a little bit. Any final parting thoughts before I end the call? And I will upload this video, by the way. I'd have to go pick up my son, but I'll make sure this downloads and I'll upload to YouTube. Nina, you have a question? Go ahead.
Were we given the worksheets for the
Yes.
practice test?
Yeah,
And,
yeah, it should be. Yeah, actually, so I have it right here. I have the, this worksheet right here, and it will be out. It's all at the end. Yeah, and it says right here. It's right there. So you don't have to print anything. It's all there for you. But I'll upload the file so you can see what it looks like. So you make sure you're doing the right thing. But it's all there.
Thank you.
Yeah, you don't have to print anything. Try to make this as low maintenance as possible for you guys. All right. Well, cool. Well, anyway, I will see you guys on Zoom 9 o'clock Tuesday morning. I'll be in Tucson, Arizona then, and I'll be probably about 100 degrees outside. But yeah, we'll do a call then, and then we'll do some asynchronous stuff. But I'll upload. I'll make sure Schoology is updated with at least the homework within the next hour, and then all the other stuff that I set forth for myself. What I set forth for myself for you guys. Yeah, I'll make yeah, the video lessons for next week. I gotta do that, obviously. There'll be Google Forms that go with that. I'll grade you guys homework probably sometime tonight or tomorrow morning. All the solutions for all the stuff we've done so far, I'll upload that. A terminology sheet I'll create for you guys. And of course, I got to write the test for next Thursday. That's the last thing. But yeah, I got some things there on my end to do for you guys. Cool, great. So let's end this call. Enjoy your weekend. It's a long weekend, which is great. And happy Father's Day. Make sure do something cool for your dads. And that's it. So I think we're all set. All right, have a great rest of the afternoon. I'll see you guys on Tuesday morning on Zoom.
Have a good one.
You too. Bye.
Thank
Bye.
you.
Bye. You're welcome.
Bye. Thank you.
Bye. You're welcome.